Hello, everyone, and welcome to this Portescap webinar. My name is Katie, and I will be your Global Spec moderator. Now I would like to introduce today's presenter. With us today, we have Antonio Herrera. Antonio works with strategic marketing for surgical robotics and hand tools. Antonio, welcome to today's event. And with that, I'll pass things over to you.
Yeah, thank you for having me. This is a very exciting time. This industry is growing so fast. And as far as of Portescap, we're very excited to support it. We're learning a lot. We're providing a lot of value. And again, great times. My name is Antonio Herrera. Support industry marketing in Portescap. I support surgical robotics, surgical hand tools, and also industrial robotics, including a couple of applications we'll discuss today. Yeah. So thank you for having me. Yeah. Today's presentation is going to be engineering human-like motion, and we're going to talk about challenges and opportunities in robotic hand miniaturization. As I mentioned, my name is Antonio Herrera, and I support industry marketing for Portescap. Starting from the basic and without boring this audience that probably already knows a lot about this. But we have to start with these foundational topics. So basically for robotic hands, key requirements, one of them is going to be robustness. And in simple terms, this is the ability to lift and hold weight. And you can also classify robustness as the ruggedness of these devices. The other important one is going to be dexterity. Basically, dexterity is tied to degrees of freedom. The more degrees of freedom this device has, the more precise and versatile the motion is going to be. So these two are definitely the two most important requirements in robotic hands. Sometimes they will go together. Sometimes one will prevail over the other one. But in these times that we're living, basically both are being pushed to the limits, and technology is the one that needs to really move in tandem with these requirements. At the end of the day, for the essential motion characteristics, the most important thing here is to replicate the human hand, right? So I've heard many times that the human hand is the most versatile tool that ever existed. And not only to replicate the hand motion is a big goal, but also the appearance of the human hand in terms of course, how it looks and the sizing. Moving to applications and design principles, again, very quickly, couple of common and commonalities and differences. In the common side is the uses. So the applications across the industries, there are probably more than the two I'm going to mention, but these two are perhaps the most well known. So one of them is myoelectric prosthesis. We have an example on the top right image right there. And the other application is going to be the humanoid robots. Right? It's very common, very popular these days. And also on the common side, we have electromechanical design, right? So you can think that the wrist, hand, finger motion is virtually identical. So designers could put together a device that could work for both applications, and this is actually happening. And basically, the electromechanical design is exactly the same. However, there are some differences. More than two I'm going to mention, but two very important ones to bring up are going to be the signal source. So the prosthesis, again, top right image right there. The commands for the motion are going to be driven by myoelectric signals. So in very simple terms, muscles on the limb can be converted. The motion of the muscles can be converted into electrical signals, and these can be passed on to the actuators to drive the motion. As simple as that. And on the humanoid robots, the signal source is basically programming or other sources, but that's one of the main differences, as well as you could say the environment where they are going to be used. You can think control versus non-control, and again, these could vary, but ideally you could have humanoid robotics in a controlled environment where you know the task they're going to perform, and you can set even the temperature, room temperature, and surroundings. Uh, on the human use, basically a myoelectric per species, these can be very wide. So a person trying to improve their lives with these devices, they're going to be exposing this to the outdoors. They're going to be perhaps taking a hiking and getting this thing wet under the rain. So again, the environment could be different for both of these applications. At the end of the day, for OEMs designing solutions, either for one industry or for both industries or more than these two industries, the ideal situation is going to be to try to maximize value by standardizing a solution for themselves. So this is an ideal situation. Can this be achieved? This is what OEMs would perhaps be interested in finding out. Continue on the challenges, of robotic hands. Two big ones that come to mind are going to be size, right? The never-ending pursuit of miniaturization. The goal is to achieve a one-to-one scale with a human hand. We may notice in the market that a lot of the recent offerings tend to be much larger than an average human size. However, several OEMs are pushing these limits in the goals to achieve a one-to-one sizing with human hands. And of course, the challenge, the main limitation is the limited space. I mean, you look at your hand and you kind of eyeball how much physical space there is put in actuators, and the technology today is the limiting factor, right? The motor, gearing, and other supporting devices to put together an actuator. Another challenge is value cost optimization. You can name these any different ways. At the end of the day, it is going to be always a balancing of performance versus cost, right? So again, different OEMs will aim to different purposes or goals. At the end of the day, it's a balance between what is the most technology I can develop and offer, and in line with affordability, right? Is my audience capable of paying for this? Is the value the maximum technology, or more perhaps a more basic motion solution? And again, at the end of the day, is stakeholder alignment. So from end users to component manufacturers and everybody in between, all of them needs to provide and give value. Continuing on the challenges and how this becomes a complex challenge here. Diverse approach is one to bring up. So I'm mentioning no one size fits all, and this comes down to OEM preferences and goals. Some OEMs will aim to serve specific industries, perhaps on the medical side, my electric prosthesis and related, or the industrial side, or maybe even both. The value to offer may differ. Some OEMs may aim to tackle a technical, best-in-class solution, a very robust or dexterous solution, or maybe a more affordable type of option for the market. So that is going to impact the way they will try to solve the problem, as well as their OEM philosophy. So some OEMs, in terms of intellectual property, integration, assembly, In the spectrum of options, some will be very controlling, and their preference is going to be to design everything in-house, assemble in-house, hold the patents, no changes allowed, and in this case, perhaps the best options, component manufacturers, tier ones, etc., would be to build to print. And in the other end of the spectrum, you may have OEMs totally open to full collaboration and actually seeking for these third parties to help them optimize and innovate, right? So no right or wrong answers, just a matter of preference. And just going to that image over there on the right hand side, basically also the location of the actuation, right? So again, different purposes, different goals. Some might decide to locate the actuation in the forearm or the palm or the knuckles or a combination of them, right? So again, we're talking about robustness, dexterity. The more dexterity is desired, the more degrees of freedoms are needed, which means more actuators, and we're playing in a limited physical space. So it's a balancing act all the time. At the end of the day, the common goal is to achieve compactness, torque density, everything within the design constraints, the physical spaces and weight limitations, and also seeking the value of cost optimization. In terms of motion and design implications, the heart of the actuation is basically the motor. There are a couple of different popular options being pursued by the market, motor with a feedback device, or even more components, such as a gearing, ball screw, and the arrangement can vary widely. In terms of sizing, we have a typical representation of the common sizes, and you can just intuitively think that the green is where we see the market today in terms of the ranges of size diameter, and pushing into, of course, always smaller, and a little bit on the right hand side where the market is could be on the larger side size of hands as of today. So smaller is always preferred, but smaller actuator, smaller motor perform less. So we're talking about less area to dissipate heat, more losses, and this is part of the challenge: how to optimize, how to innovate to bring solutions here. And as I mentioned on the design implications, different OEMs have different philosophies, different goals and purposes, and that leads to unique requirements for each of them. So the way we see this is flexibility is needed for customization, right? So have tailored solutions for specific OEM preferences, as well as integration and having that holistic approach to put all the components together in the most optimum fashion for the application. How to solve this problem? Not an easy problem to solve, but there are different approaches that could be taken. And one of them is, okay, so different OEMs have different needs. So customization, optimization. One excellent way to start is weighting out different motor topologies. And the idea is to select the best starting point for specific performance requirements, basically technical requirements. In the examples we have here, we're weighting out slotted versus slotless technology. There are other type of motors that could be considered depending on the OEM needs. For example, brush DC motors and even other type of motors. But basically, when we look at brushless, which is in most cases the preferred method based on efficiency, we can run a quick comparison of the different topologies in terms of typical customer requirements around speed, torque, inertia, mechanical and thermal resistance. And the idea is, what is the best starting point for a true customized, optimized design that can help these OEMs achieve their unique goals? Other parameters we can consider, and we actually consider during once we engage with customers uh, through engineer to engineer discussions, understanding their goals, understanding the challenges, is a consideration of, for example, the motor, the form factor, right? So depending on the location of these actuators, form factor is going to be definitely a critical criteria. Considering the motor, speed versus torque, what is that duty cycle looking like, optimized around available voltage, optimized again around the desired torque versus speed outcome, balancing the motor sizing, so the OD times the length for thermal efficiencies and optimum performance. We mentioned that heat and losses is the enemy of progress here, and a small motor is more limited in those areas for heat dissipation. So how to optimize the available space, the OD and the length and the motor topology and all of these factors to truly optimize and, and get the most out of the actuation. Considerations that come from understanding the customer needs not only include the duty cycle and the thermal management. Some customers may prefer to run the motor a little hotter because perhaps the environment or the application allows it. Some others prefer to be a little bit more conservative for whatever reason. It's part of the specifications, and that is going to basically allow the motor designer, the actuator designer to work around, as well as consider all the preferences of commutation methods for feedback devices, try to optimize and provide the, the items, the components that really provide the customer what they need, as well as interface preference. And we're talking not only on the mounting side for shaft, uh, as well as connectivity, connectors, etc. So consider choosing the right partner. There are a couple of high-level criteria we're going to mention here. One is a miniaturization, right? So how to deliver the maximum performance in the smallest and lightest form factor, whatever that is. Collaboration, so that engineer to engineer, truly listening, understanding what is needed, and provide exactly what is needed, not more, not less. Customization, this comes around flexibility and willingness to truly provide that solution, not to be too rigid around this is the option we have, but truly understand and provide that optimization. And that fits into integration, which is basically embracing that holistic approach and understanding all the components. We saw a couple of slides ago, the motor feedback device, gearing, screw, and perhaps even more to really optimize that solution. Early engagement, definitely very important. A good way to start for development is typically off-the-shelf solutions. They're great for quick prototyping, but they can be limited for long-term. Basically, early collaboration can help maximize finding the right solution from the get-go, basically through a tailored solution, and also choosing the right product and technology to avoid missteps and to minimize redesigns and delays. So in this chart, we consider the green portion is where truly maximum collaboration happens. as early as possible, understanding and designing around the right solution to prevent mistakes and iterations down the road. Factors to consider not only include the technical solution, but also manufacturability and sustainability, long term for scalability, and even allow for potential changes down the road. Why Portescap? Couple of reasons we consider Portescap a great value for as a partner is our Swiss engineering heritage, and what that means is a passion for precision, customer-centric innovation, and technical excellence, as well as a global footprint. Portescap counts with engineering centers of excellence and also customer service hubs around the globe. And drilling down into the engineering expertise to truly achieve optimization and to look at applications holistically. Other innovations happening within Portescap across robotics, also solutions outside of these conversation, this session we're having here, but an adjacency is going to be other appendages for humanoid robots like wrist and neck, considering bionics, myoelectric prostheses, also lower body limbs, exoskeletons, precision grippers for collaborative robots, and surgical robotics, which is a topic we discussed a few months ago also through Global Spec. Hopefully with this slide, this busy slide, the audience can recognize maybe one or two brands. At the end of the day, Regal Rexnord is the parent company of Portescap. It holds over 60 brands across various business segments. So we see them there on the left-hand side, we see all the brands on the right-hand side. And a lot of individuals may not know that all of these are part of the powerful portfolio of Regal Rexnord. When we put attention on automation and motion control, there are many brands that are truly collaborating among themselves to bring solutions and to support the applications in robotics, including robotic hands and humanoid robots, exoskeletons, myoelectric prostheses, etc. So drilling down into that group, we have a few brands to mention. Portescap, I represent Portescap, and we'll be talking a little bit about the main criteria we looked at when we really engage with customers and work with them to help them solve problems, as well as Boston Gearing with high precision gearing, Cole Morgan for frameless direct drive motors and other type of motor solutions as well. Nook and Thompson with precision screws and linear guides, and Warner Electric with electromagnetic brake and clutches. All of these brands working together, collaborating to provide customers with horizontal and vertical approach to in the ability to integrate to truly provide a holistic solution. So thank you for your time. Again, interesting times we're living, and Portescap is very proud of supporting this very amazing industry. Thank you.
All right, thank you so much, Antonio. So now let's get into our Q&A session. All right, our first one today. What does a typical robotic hand solution include, and how are its components integrated?
Okay. As I mentioned previously on one of the slides, different approaches by OEMs, but typical requirements we see are going to be motor plus a feedback device, or also including a gearing and a screw. So at heart, as I mentioned, the motor is what drives the actuation. Optimization starts there. but also considering the total physical space, and the form factor is what drives, what is the best method to solve the problem of motion for robotic hands.
All right, thank you so much for that answer. All right, next question here. Which performance feature is most critical to OEMs when selecting electromechanical components?
Yeah, excellent question. And as what we see based on our experience and working with customers, that the two items that come on top are going to be miniaturization. So these relentless pursuit of reducing the size and the weight of the total solution. And the other one is going to be the value. So value can mean different things, but at the end of the day is how to obtain a solution that maximizes the performance and is well balanced with affordability for the solution the OEM wants to put on the market.
Antonio, thank you so much for that answer. All right, looking at the queue here, next question. How do application needs influence the choice between dexterous hands, robust hands, and simple grippers?
All right, excellent question. Dexterous hands is going to require more degrees of freedom. So assuming that the OEM is aiming to maximize the resolution of the motion of the hand, it's going to be perhaps a more busy solution in terms of number of actuators. So space is going to be a key factor here. When it comes to robust hands, the OEM is aiming to maximize the ability to lift and hold loads, and even perhaps the robustness of the ruggedness, is what I meant to say. So how rugged can this device can be to withstand the environment and abuse. And when it comes to grippers, it's basically a more repetitive application. The motion is simpler, it's probably faster, and the motion that the application requires is more predictable. So a simpler solution, perhaps the physical space is not as important, but perhaps value in terms of cost and reliability of this repeatable solution in a fast pace is more important.
All right, thank you so much for that answer. Next question. Are there design or control similarities between myoelectric prostheses for human users and robotic hands for humanoids?
Excellent. So as I mentioned before, in terms of similarities, the electromechanical design could be basically the same, and it's proven that OEMs we work with that they're aiming to maximize that as part of the value they're seeking. Spanning it across different applications, different industries with the same device, the same solution, is super valuable, right? It can allow them to have scalability in a single part number, ideally. And the other point in terms of differences is going to be the signal. Again, I mentioned that myoelectric prosthesis, if we envision a human hand muscles, the muscle motion can be converted into electrical signals and feed the actuation of that hand. And in terms of robotics, is basically a programming or even AI.
All right, thank you so much, Antonio. We've got time for a couple more here. Next question. Beyond hands, does Portescap support motion solutions for other robotic limbs or axes?
The answer is yes. Within the industrial side of robotics, other applications supported by Portescap include exoskeletons, automated mobile robots, AGVs, and even outdoor mobile solutions for surveillance, for example. as well as a couple of other applications, including grippers for collaborative robots, for example.
Where are the products manufactured, and how does this impact quality or lead time?
Portescap has different plants in the world, uh, again, center of excellence and engineering support, but as well as when it comes to manufacturing locations, there are different plants specific to Portescap, as well as many assets held by Regal Rexnord, over 250, I think close to 300 plants in the world that could be leveraged and basically bring that flexibility, right? Depending on which part of the world is preferred to have the manufacturing for cost, for supply chain, etc. Those are definitely resources that Regal Rexnord and Portescap can leverage to optimize value, maximize value for customers.
All right, Antonio, next one here. What additional capabilities or services does Regal Rexnord provide?
Yeah, as I mentioned, different brands, over 60 different brands within the Regal Rexnord portfolio. But when it comes to these applications of humanoid robotics, bionics, myoelectric prostheses, exoskeletons, these adjacent applications for this session, definitely various brands like Cole Morgan, Thomson, Thomson Linear, Warner Electric, Nuke. Again, we have gearing, we have linear actuation, we have bigger motors than Portescap that complement Portescap offering, and the opportunity to holistically integrate them and bring value from a sub-assembly integrated solution.
All right, just a reminder to our attendees, if you don't hear your question being answered, don't worry. We'll get back to you following today's webinar. We've got time for a couple more here. This next one is asking, what sets Portescap apart from competitors in the motion control space?
I would say that one of the biggest reasons is the flexibility and willingness to customize, to optimize solutions for customer specific requirements. Again, deep engineering to engineering, very purposeful listening of what customer needs. And going back to that slide, I showed there are four big components. Portescap is truly a good partner, considering miniaturization. So the technology expertise and capabilities to push the limits, uh, optimization, customization, so the willingness and flexibility to really put a solution that customer thrives for. Integration as well, so look at solutions holistically, understanding all the components in the actuation and even outside interfaces to really maximize a solution. And miniaturization, integration, customization, and collaboration. Uh, Again, that truly engineer to engineer understanding and also educating customers in terms of motors, gearing, feedback devices to select the best topology and the best option for that.
Okay, thank you so much. And this is going to be our last question for today. Feel free to enter any questions you have into the QA window. We will get back to you following today. So our last one for today, Antonio, what's the best way for OEMs or developers to begin working with Portescap and Regal Rexnord?
As early as possible, we mentioned that true collaboration starts at the very beginning when a company, an OEM, an engineer is developing a solution, it's visualizing all the requirements, the goal, the purpose is already clear for them. Uh, Through engagement and collaboration with Portescap, that's the best moment to start looking at those topologies, understanding the motion profiles, understanding the working points, the goals, and then finding the optimum solution. Again, several different technical factors we look at. We look at the available voltage. We look at the speed sort curves. We look at form factors in optimizing around all of those parameters.
All right. And with that, we are going to start to wrap today's webinar up. So first, I'd like to say a huge thank you to Antonio for a great presentation and for answering some of our attendees' questions. So thank you so much for being here.
Yeah, thank you for having me. Again, very fun times we're having. We really enjoy and love learning and understanding and advancing technology and truly providing value to customers. Again, engineer to engineer collaborations, early discussions, early engagement, and the holistic approach to really optimize and bring value to the customers. So yeah, thank you for having me. Excellent. Please keep inviting me to the next one. Really appreciate it and have a good day. Thank you all.